Hello, this is video 3 for CS1124. I'm sure you'll recall the last video talked about inheritance, which is a very important concept in object-oriented programming. Video 3. We're still talking about inheritance. Here's another inheritance example. Intended to answer that burning, nagging question, what does this have to do with us? Here's what it has to do with us. At the top, our base class might be something called a graphics object. Well, I'll just put graphics. It's a graphics object if it's one of those things, if it's inside the graphics class. What might a graphics object be, more specifically? Because graphic, wow, that is extremely generic, is it not? Well, it might be a circle. So circle might be a more specific type of graphics object. That's how those fit together. Something completely different, but still might count as a graphics object that we could draw and we could see, might be a text object. And yes, I'm still using those UML arrows to show that that text is a text object is a graphics thing, and it's going to have all sorts of attributes that graphics objects have, like whether or not it's on the screen, what color it is, maybe all that kind of stuff. And a circle has the same stuff. Now, to illustrate some of the other terms, I'll use purple before it completely dries up. You know, one of the annoying things, this is an aside, one of the annoying things is I've started losing caps to whiteboard markers already. I've already lost 3, and I have no idea where they went. They're not in my pockets. They're not on the floor as far as I can tell. It is very annoying. Okay, now we're back. Up here, the graphics objects, the mutator. Mutator is a particular kind of method that changes a characteristics of the object, also known as an attribute of the object. So we're going to mutate it using a special class of, what was that other word now? Method. We're going to change an attribute. So something like setFill might be a mutator. SETFILL. Yes, please still offer feedback about the colors, the font that I'm using, the size of print, and all that sort of stuff. But I'm claiming a graphics object might very well have a mutator called setFill, which sets the fill color or the background color to green or blue or whatever you want your background to be. That's a possibility. Also, if it's something like a circle or a line or whatever, it might have setWidth, which says maybe how many pixels on the screen or how many points or whatever it is, how wide that line is on the screen or how thick that circle is or the rectangle is or whatever. So both of those would be mutators because they're going to change some stuff. Other methods that don't mutate, those are called accessors. ACCESSORS. Accessors observe something or look at something. They look at one of the attributes, but they don't change them. An example might be draw. Not in the Old West sense, but in the sense of draw yourself on the screen. Now, this is a strange idea, but it's common in object-oriented programming. Objects know how to do lots of things with themselves. So we might be able to tell a graphics object, draw yourself. I've already set your color, I've set your width, I've filled you in with text and so forth. Okay, make yourself visible. So rather than having this show up incrementally on the screen, we can do all that stuff sort of behind the curtain in the background and then tell the graphics object, draw yourself. But the draw on the screen does not change anything about the attributes of the graphics object behind the scenes. All it does is look at those. Oh, you want me to draw you? Okay, let me see. Well, what's your background color? It's green. I'll make the background color green. What's the width? The width is, I don't know, 10 pixels, whatever it may be. I'm just making this stuff up. So the draw has to look at all those attributes, but it doesn't change any of them. Here's a weird one that's also common in object-oriented programming. Clone. Clone yourself. I guess we could think of that as one way that objects reproduce. They can clone themselves, make an identical object to themselves. That comes in handy in some circumstances. And I didn't leave much room for text and circles, but I'm going to keep going anyway. Text is a subclass of superclass graphics. That's another Another set of terms, just like the base class and derived class. Graphics, I'm going to say, is our super class. Super class. Text, then, is a subclass of graphics. So is circle. Circle is a subclass of graphics, which is a fancy schmancy new term way to say that circle is derived from base class graphics, and therefore a circle object knows how to do everything a graphics object knows how to do it. Now I'm repeating myself again, and I'm not going to do that anymore. Mutator for text that we might not have for graphics objects in general. Mutator is a good science fiction-y term, isn't it? Change the state of this object. Something like set style. Maybe we can set the text style to Comic Sans and irritate a lot of people online. That seems to be a very unpopular font. We could set it to Times New Roman. Maybe we could set style to Courier or whatever, Courier New. So there's an example of a mutator that might work for text that doesn't make any sense for other types of graphics objects. We might have an accessor, almost a trivial one, get text, where text there does not mean get yourself object. It means get me whatever string is being printed out, whether it's have a nice day or whatever that may be. Get text will look at the string that's set inside the text object, and I hope this makes more sense than my explanation does, but get text will get that string that's stored inside the text object that's going to show up on the screen when we tell it to draw itself. There, you're going to have to replay that if you want to untangle those words. The child circle over here, the subclass, it might have something like, well, we haven't looked at the constructors yet. The constructor is like turn on and off. Constructor is a special class of mutator that means make a brand new one. You don't always have to clone an object to get a new object. You can also use a constructor, which serves the purpose of just stamping out a brand new one based on all the things that we've defined that a circle object should have. So the constructor, these typically have the same name as the class, unfortunately. So circle is actually the name of a method on the circle object. If I say circle space C, or circle space sun, S-U-N, that says that the sun, S-U-N, is a circle type object, and it gets all the privileges and honors they're associated with. All the attributes, all the methods, all that other kind of stuff. It might have an accessor, get radius. Where all it does is look at the current radius of the circle, which will be a property or an attribute, and get radius will get that back for us. And we can print that out on the screen in a console window or whatever we want, something like that. Now, the point of all this is, again, we've got the general stuff grouped together. Everything that's an object everything that's a graphics object will need to have stuff like a background color, we'll say. So set fill, that might be a mutator up there where I haven't listed any, but the property then would probably be fill color or something like that. Fill color and width would also be a property we could expect, and so forth and so on. You know what? You are really, really going to have to take notes on this stuff, write questions in your notes, and bring this stuff up when we have our chat conversation at the end of the week, because I really miss having the back and forth of people asking questions and getting me to go into more detail and fill in the gaps and define undefined terms and all that sort of stuff. And it's really hard to do that all by myself, to play both roles. So you got to help me out. Come on, help me out there. Why do we need to know this? I said that this was a more practical example. Well, you know what? I didn't make all that stuff up. There is a graphics library in Python, and to go with it, fortunately for us, a graphics reference sheet. It's a PDF file that's attached to the email that has the link to this video, and it talks about all this stuff. This is just a tiny little subset of all the things that are possible. Actually, let me see, I cross-reference this a little bit. Graphics object are the objects type 3. So if you see a chapter 3 or section 3, in your graphics reference guide, you'll see, yeah, that has all of the methods that we could use on graphics objects. What about the circle? Well, the circle is actually 3.3. Look what they did there. They even almost inherited their section and subsection titles and stuff based on the inheritance. A circle is an object type 3.3, which means that it's the graphics object, and then within that, it's type number 3 of the graphics object. Text is 3.7. So when you get your handy-dandy graphics reference PDF as in an email, if you have a printer, I don't know, I'm old school, I like to have things on paper so I can highlight them easily and all that kind of stuff. Just because I'm old, you know that. But you might be able to do perfectly well just looking at the PDF on your computer screen and get all the pieces you know, and it makes it searchable and all that other kind of stuff. But here's where we're going with this. This graphics stuff that's in this graphics reference, we'll be able, after you have your own copy, whether it's electronic or paper, I'll be able to talk about specific sections here, and I will do that. I will be talking about this and say, okay, now look at page 3, the 3.1 point methods. Is everybody with me on that? If I say that in a video, I'm assuming that you have the copy, some sort of copy, electronic or otherwise, that I've emailed you, and that you're able to reference that with me, because I can't write all this stuff on the board. I'm not even going to try. And probably, not certainly, but probably the very next video in this series will be where I type in their tiny little graphics example program. I keep showing this to you, but you'll see it when you get it. There's a tiny little program right here in the middle of the first page that sort of illustrates a very, very basic use of these graphics things in this graphics library. These are all graphics objects with inheritance and all the stuff we talked about so far, properties and methods and everything else. We're going to be using this to draw colorful candy pictures on the screen, and it is cool as heck. You can't wait. I know you can't. But I will do a demo of this. There will be a lab associated with this. The lab might not come until the next round of videos, but I will demo this, and I would recommend, here's what I recommend, even though it's not officially a lab assignment, I'd recommend you go ahead and download the graphics PY, which will also be an attachment to the email that has a link to this video at the whole of the bottom of the C. When you get to graphics.py, put it in the same folder where you're going to have your Python programs for this class, and type in this tiny little example program and see if you can get that to work. Then you'll have a starting point, and when you see me do a demo, what I'm going to do is start with this and then go to town. Just dump all kinds of other graphics objects in there and change the color and change the width and all that other kind of stuff just to show that I can. I recommend you do that on your own. It's going to sink in a lot better if you do that yourself either after or before you see me do a demo on screen next time, which will be video 4. But you know what? I think that's enough for video 3. So I'm going to close this one up and say, see you online. And try not to increase it in volume before I turn off the video.